Compounding interest is another example of exponential growth. It's just a very specific case of it. And so what happens, this is what happens when you have money in a bank account. Okay, you get compounded interest. So your interest is calculated both on the principal, so what you put in there initially, and the accrued interest, so what the interest that you have earned up to that point. So here's going to be our formula. We're going to keep it A equals, the big A for the amount. That equals a capital P. That stands for the principal, which is just a fancy word of saying your initial investment. So whatever you put in that account first is the principal, and that's what goes first in the formula. Okay? Then it is parentheses 1 plus R over N. R is, of course, the rate expressed as a decimal. Okay, we convert it to decimal form from percent form. N is the number of times per year the money is compounded. Okay, so it'll say something about interest is compounded quarterly. Okay, quarterly would be 4 times in a year. It could be compounded every month, so that would be 12 times per year. Okay, N is the number of times per year the money is compounded. And then we're not finished with the equation. That is raised to the N times T. So the N is the same, and T is the time in years. Okay, so let's look at an example. Number 5. Laura deposited $12,000 into an account. Deposited is a key word for that's her initial investment. So over here to the side, I'm going to write P equals 12,000. Or if you want to start filling in your equation, you can do that. A equals 12,000. 1 plus, let's keep reading, into an account that earns 8% interest. So that means our rate is equal to 0.08. Make sure you convert it to a decimal. Okay, 0.08. So 0.08 is going to go here in our equation. How much money will she have in 5 years? That is T. If the interest is compounded quarterly. Okay, so that's N. Quarterly means 4 times in a year. So let's fill in the rest of our equation. Okay, so that's what your equation should look like on your paper. 12,000 times 1 plus 0.08 over 4 raised to the 4 times 5. Now, this is really easy. You just have to set up the equation, but you got to be careful when you put it into your calculator. Okay, this is where most people mess up because parentheses are important. Parentheses are important when you put it into your calculator. So I want everybody to grab their calculator and do this along with me to make sure that you're doing it correctly. Okay, 12,000 parentheses. Now here's the easy part. You don't have to add any more parentheses right here. Okay, you can just type this in exactly how it looks because we really do just want the 0.08 to be divided by the 4. Okay, we really do just want that part. Now, here's where you have to be careful. When you raise it to the power, you're multiplying 2 numbers in that exponent. So here's what you need to do. Either you need to just go ahead and multiply those numbers, 4 times 5, and put 20 right here, okay? Or if it's something you're not comfortable with multiplying in your head, then you need to put parentheses around it, okay? You need to put parentheses around the 4 times 5. Because if you do not put parentheses around the 4 times 5, let me show you what happens. Okay, $17,831.37 is the correct answer. $17,831.37 is the correct answer. But I've got it typed in right here without parentheses around the 4 times 5, and it gives me $64,945.93. That's significantly more than 17,000, right? Hopefully you realize that those are significantly different. That is not the correct answer, okay? Because what your calculator has done is it follows order of operations. It applies that exponent and then multiplies the whole answer by 5 if you don't put the parentheses around the 4 times 5, okay? All right, let's do another one. It says Jack took out a 6-year loan for $25,000. So $25,000 is P. That's the initial amount. It's not an investment here. We're talking about a loan, but that's the initial amount. It's $25,000 to purchase a boat at 4.5% interest. So our rate, express it as a decimal, so 0.045. If the interest is compounded monthly, so how many months are in a year? 12. So N is 12. What will he have paid total over the course of the loan? So let's set up our equation and see what else we need. So we've got 25,000 for P. 1 plus, we know the rate. We know N. We know N. Do we know T? What other piece of information is given to us in the equation? It's a 6-year loan, and they want to know how much total he will have paid over the course of the loan. So that's what's going to give it. We're calculating this for 6 whole years. So 6 is the T. All right, so let's see here. Y'all type it in as I'm typing it in. See if you can do it correctly. 25,000, 1 plus 0.045 over 12. Did you get $32,732.58? Okay, awesome. So that's not a terrible interest rate. 4.5% interest is not awful. You can get a little bit lower, but that's really not that bad. But for a 6-year loan for $25,000, he ends up paying almost $33,000. So almost $8,000 in interest. That's something to keep in the back of your mind when you graduate from high school and you get you a job and you think, oh, I can get me a new car because I can afford a car payment. Take a second and think about how much money you're really going to be paying for that new car that you really want. Okay? So you're always asking, how are we going to use this in real life? This is how it's used in real life. We're right here. So it's great. The bank will let you borrow money. They will. But they're going to get their money too. Okay, let's do a few more just to make sure we got it. Number 7, an investment account pays 3.9% interest compounded semi-annually. Okay, so the rate is 0.039 compounded semi-annually. Does anybody know what semi-annually means? Okay, it could be every other year or twice a year. Okay, Typically, semi-annually is considered twice a year. Biannually would be every other year. So semi-annually is, that would be n equals 2, twice a year. If $4,000 is invested in this account, that's our P. What will be the balance after 12 years? That's our T. Excuse me, thank you. So our amount equals the principal, 4,000 times 1 plus the rate, 0.039 over 12, not over 12, over 2. Okay, raised to the 2 times 12. $4,001 plus 0.039 over 2 raised to the, I'm going to go ahead and multiply out those two numbers so I don't have to type in a bunch of parentheses. $6,358.48. Okay, number 8. A savings account offers 0.8% interest. So not very much interest at all. What is our rate here? 0.008. We've got to move it 2 places. So 0.008 compounded bi-monthly. Bi-monthly. When I see bi-monthly, I think every other month. Okay, this is one of those, I don't like using bi-monthly because it can be interpreted 2 ways. It can be interpreted as every other month, or it can be interpreted as twice a month. So I avoid using bi-monthly in the problems that I get. So I'm going to go with every other month for bi-monthly. So that would be 6 times in a year. If Bob deposited $300 into this account, so that's our principal, $300. How much interest will he earn after 10 years? So T equals 10. So let's set up the equation. A equals 300 times 1 plus 0.008 over 6 raised to the 6 times 10. Crunch the numbers. We get $324.97. Oh, and actually, hang on, let's read the details. That's not the actual answer to the question. It says how much interest will he earn after 10 years. So that's the value of the account after 10 years. He started with $300, so he earned $24.97 in interest. So make sure that you pay attention to the details of the problem. Okay, number 9. Suppose you invest $750. Invest, that means principal, $750. Into an account that pays 3% interest, so R is 0.03, compounded weekly. How many weeks are in a year? 52. 52 weeks in a year. How much interest will you have earned after 20 years? So T equals 20. So here's another one. How much interest is the answer to the question? So 750, 1 plus 0.03 over 52 to the 52 times 20. Okay, so the account is worth $1,366.35, but we invested $750, so the interest equals $616.35. Okay, so not difficult, right? We just need to know the equation and interpret those words, but it's pretty much same keywords all the time.